This exercise is on how to do electronic configurations. Electronic configurations are expressions as to how electrons are distributed to its corresponding orbitals in terms of energy levels and orbitals. The components in doing the electronic configuration of an element or ion are as follows. The large one indicates energy in terms of size and amount of energy that the orbital has. The S indicates the orbital as to what shape the electron will be confined in. The superscript 2 indicates the number of electrons in the orbital. The Aufbau principle is in German meaning building up, meaning electrons as to how they are being filled from lowest energy orbital to highest energy orbital. From our periodic table, the lowest energy orbital is 1s and continues to 7p. Here is the periodic table on your left and the electronic configuration periodic table shown on your right, illustrating the regions where the s, p, d, and f orbitals are located. The first example is hydrogen with an atomic number of 1, so it has 1 electron. The electronic configuration for H is 1s1. The second example is fluorine with an atomic number of 9, so it has 9 electrons. The electronic configuration for F is 1s2, 2s2, 2p5. The third example is zinc with an atomic number of 30, so it has 30 electrons. The electronic configuration for Zn is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Orbital diagram provides some insight as to where electrons belong based upon its energy level and subshell. Pauli exclusion principle states that no two orbitals can have the same 4 quantum numbers. In simple words, the 2 electrons in the orbital cannot have the same spin, but of opposite spin, 1 arrow up and 1 arrow down. Hund's rule states that if you have a subshell with more than 1 orbital of equal energy, electrons are placed singly before filling up the orbital of opposite spin. Let's look at some examples. Here are the orbital diagrams for elements in period 2 from Li to Ne. However, there are some exemptions. Elements in group 6 or 6b, where 1 electron from the s orbital moves down to a d orbital. Chromium has electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5, not 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4, for stability purposes where each 3d orbital has 1 electron per orbital. Another example is for elements located in group 11 or 1b, where 1 electron from the s orbital moves down to a d orbital. Copper has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10, not 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9, for stability purposes where each 3d orbital has 2 electrons per orbital, resulting in all of the subshells in energy level 3 filled to capacity. Next, a discussion on noble gas configurations. This notation involves a fragment of the ground state configuration being replaced by the noble gas written in brackets. Let's look at the electronic configuration of the noble gases. As you can see, the noble gases are located in group 8A or 18. Helium has an electron configuration of 1s2. Neon has an electron configuration of 1s2, 2s2, 2p6. The rest of the electron configurations are seen below for argon, krypton, xenon, and radon. The first example is oxygen with an atomic number of 8, so it has 8 electrons. The ground state configuration for O is 1s2, 2s2, 2p4. And since the nearest noble gas it passed was helium with an electron configuration of 1s2, the noble gas configuration of oxygen is He in brackets 2s2, 2p4. The second example is calcium with an atomic number of 20, so it has 20 electrons. The ground state electron configuration for Ca is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And since the nearest noble gas it passed was argon, with an electronic configuration for Ar is 1s2, 2s2, 2p6, 3s2, 3p6, the noble gas configuration of calcium is Ar in brackets 4s2. When writing the electronic configuration for ions, it can be done where the following rules are to be applied. 1, if writing the electronic configuration of an anion, add electrons to the outermost shell. If writing the electronic configuration of a cation, remove electrons from the outermost shell. Let's look at an example of each. The first example is calcium ion, or Ca2+. Calcium has a ground state electronic configuration for Ca is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. The calcium ion with a 2+ charge has an electron configuration similar to Ar, which is 1s2, 2s2, 2p6, 3s2, 3p6. The second example is fluoride ion, or F1-. Fluorine has a ground state electron configuration for F is 1s2, 2s2, 2p5. The fluoride ion with a 1- charge has an electron configuration similar to Ne, which is 1s2, 2s2, 2p6. Exercise 1 is to write the ground state electron configuration for the following elements: Pb, Ni, and Sr. Exercise 2 is to draw the complete orbital diagram for the following elements: Mn, Se, and K. Exercise 3 is to write the noble gas configuration for the following elements: Ga, Zr, and Br.